guys, like I say, today we are finishing off our transformation geometry. We have learned about 4 different types of transformations in this course. I've sort of just jumped straight into it, but just that we all know what those 4 transformations are. They are translations, which is when we move a shape or a point up, down, left, or right. They are reflections, so it's creating the mirror image of a point or a shape about a line of reflection. Rotations, so turning a point around a central point. And then finally, what we call dilations, but basically enlargements or reductions. So either making a shape bigger or smaller according to what we call a scale factor. So hopefully we're going to get through at least an example or 2 of these in this lesson. But like I say, if we don't, or if you're feeling confused, please do go and watch the videos on Watobe's website because we've done all of them. So you can go and recap them there. All right, guys, remember, know how to take a screenshot on your device. Just because obviously, as you can see, there's diagrams and stuff, and you don't want to waste time trying to draw them now. So be able to take a screenshot so that you can refer back to them as we go along. And as Yolanda says, I'm going to ask for answers. I'm going to ask questions, and you're welcome to put your hand up or put your answers in the chat as we go along if you are feeling like you'd like to answer the question. Alrighty, so let's have a look at our first one. Whoops. This was the first type of transformation that we did, which was a translation. And the instructions tell us to translate the triangle ABC 2 units up and 3 units left. Now, as you become more and more comfortable with these things, you'll start to be able to sort of place your shape appropriately according to the instructions given to you. But remember, there is always a way to help yourself get to where you need to be. So what this is essentially saying is that every single coordinate needs to undergo this transformation. So A, B, and C, all 3 of those need to be moved up, and they need to move left. So that's exactly what I'm going to do. Coordinate A, I'm going to move 2 units up, and then I'm going to move 3 units left. And where I end up is now my new coordinate A. Remember, obviously, when we label these coordinates, we use a little apostrophe. And so in this case, oh, that's not great. In this case, A dash, or the new coordinate of A, is now at -4, 0. Remember as well, guys, that coordinates are always written X first and then Y. So we always read the X coordinate first and then the Y coordinate. Right, would anyone like to give me, and you can put it on the chat or you can raise your hand, would anyone like to tell me where the new coordinate B dash would be once we move it 2 units up and 3 units left? Okay, Bayanda, do you want to tell us?
Yes, Miss. Hello, Miss.
Hi.
Can I please try?
Yes.
It's going to go 2 units up, and then it's gonna land on 1. And then it's gonna go 1, 2, 3. It's gonna land on -2.
Good. So over here.
Yes.
Excellent. So guys, B dash is going to be exactly at -2, and then 1 on the Y axis. Well done, Bayanda. Thank you.
Thank you.
Alrighty. I can already see some other hands. So Bontle, would you like to give us C?
Yes, ma'am. C is going to be 5, -1.
Oh, my counting. 1, 2, 2 up, 1, 2, 3 across. So do we agree C dash is going to be at 2, -1? Because we still need to move left.
-1.
Excellent. Well done. Okay, guys. So once we have our coordinates, we can then draw in our shape. Now, obviously, these little like bunny hop things I would do in pencil so that I can erase them nice and easily. And once I've done that, oopsie, I can now go draw in my triangle. You're obviously going to use a ruler. I am very clearly not using a ruler. and you will draw in your triangle. Okay, yours will look prettier than mine. Remember that we always label the coordinates with the A dash, the B dash, or the C dash. You only have to write the actual numbers if you are asked to label the coordinates with the values. If you are in doubt though, you can always add the numbers next to the coordinates if you want to. So there's nothing wrong with adding the actual value of the coordinate with its label. It does become a bit crowded sometimes, but it really doesn't matter. But what you do need to have is at least the letters with the dash. Okay. So take your screenshots. Hopefully we're all happy there. We've got another one that we're going to try. So let's have a look. Okay. So question B is asking us to take this quadrilateral ABCD and translate it 4 units down and 3 units right. So I'm going to give you a second to have a look at this. And I'm going to then ask for someone to, or you can start raising hands or putting it in the chat. I want to know the coordinates of A dash, B dash, C dash, and D dash. So once you sort of know where they're going to be, once you've moved it down and right, you can raise a hand and let me know. Just want to get a better color here. So remember, each of those 4 coordinates must move 4 units down and then 3 units right. I'm just going to give everyone a second to have a think and have a try. All righty, Matlogonolo, do you want to tell us? Let's start with A dash.
Ma'am, A, it's -3 and -2. Ma'am, can you hear me?
Perfect. Yes, no, sorry, I just had to get my head around it. Excellent, well done.
Okay,
so A dash is -3, -2. If we're a bit confused, as I clearly was, 1, 2, 3, 4 units down, and then 1, 2, 3 units right. Takes us exactly to that coordinate. Excellent, well done. Okay, Wangi, would you like to give us B dash?
Ma'am, B dash is -3 and -5.
Excellent. B dash is over there at -3, -5. Again, 1, 2, 3, 4 units down and 3 units right. Oh, my bunny hop's a little bit weird, but exactly there. Makuru, would you like to give us C dash?
Ma'am, 1, 2, 3. It's -4, 1.
2. You and I are on the same page. Excellent. So C dash is at -4, +1. 4 units down and 3 units across. No, thank you. And we get C dash. Right, Bongonele, would you like to give us the last one, D dash?
I'm not sure if it's right, but I think it's -3 and 1.
Excellent. So D dash is at -3, 1. Perfect. Well done, guys. And so now once we've got our coordinates, we draw in our sides. So we join A, B, C, D, and A. Oh, that's a weird looking quadrilateral. Yours will look better because hopefully you would have done it with a ruler. And we get our new quadrilateral A dash, B dash, C dash, D dash. That has been moved according to the instructions given to me. Right, so take your screenshots. I see Sitle's hand is up. Sitle, do you have a question?
Ma'am, I have a question for C. Isn't 1 supposed to be first because we use X before Y?
Oy vey. Thank you. Well done. Exactly. 1, -4. Thank you so much.
And D, ma'am.
Aye. Guys, my brain, I'm sorry.
No problem, ma'am.
Thank you,
cool.
Sihle. Right, I do apologize. I mixed up my coordinates. Common mistake. Don't do what I've just done. Remember, as Sihle said, X first and then Y. So for both D and C, it should have been 1, -4 for C dash, and then 1, -3 for D dash. I do apologize, guys. Who knows? My brain wasn't working. Alrighty, I'm going to assume we've got our screenshots. Let's have a look at our next one. So the next transformation that we spoke about were reflections. So remember, a reflection is a mirror image of a point or of a shape, and we always need to know the line of reflection. Now, in grade 8, we generally deal with 2 lines of reflection, and in this case, I'm telling you to reflect it about the y-axis. Now, that just means my y-axis is my mirror. And so what I want to do is I want to reflect the shape and create its mirror image across the y-axis. Okay, now what we need to remember is that the mirror image that we create must be the same distance away from the line of reflection as the original. So when we go and have a look now at finding my mirror image, I need to use that logic. So the original coordinates of A, and let me use the right colors here, was at -5, 1. So that means the original A coordinate was 5 units away from this line of reflection, which means when I create the mirror image, the new coordinate A must be 5 units away from the line of reflection. So my new A dash coordinate, let's hope I write it down properly this time, is going to be at +5, 1. And I've then created that mirror image for A. I need to do the same thing for B and C. So I can see that B is 2 units away from my line of reflection, which means on the mirror image side, it's also going to be 2 units away. So B dash is at +2, 1. And C, we can see is 1 unit away. And so C dash is then at 1, 4.
Okay. I think that we need to take screenshot of the previous one and this screenshot here.
Okay, I'll go back to the previous one now, guys. Just let me finish this. So we draw in our triangle and we can see that we've created the mirror image of triangle ABC, and we've created A dash, B dash, C dash. Again, remember, you need to at least label it with the letters. If you are asked to write the coordinates, you can do that. If in doubt, you can always put the coordinates on as well. But so take your screenshot here, and then I'll quickly go back up to question B so you can take a screenshot. Okay, here's question B if you didn't get it. Right. So guys, what's quite important to notice is that when we are doing this reflection, we can see that something's happening to these coordinates as we change. Now, you don't have to stress too much about the rules, but later on in like grade 10, grade 11, when we start to apply these sort of concepts to more or different sections, understanding this change is quite important. So what we can see here is if I write down the original coordinates of my triangle, so A was at -5, 1, B was at -2, 1, and C was at -1, 4. What we can see by comparing the original coordinates with the new coordinates is that all of the y coordinates stayed the same. And we can see that because all of these second coordinates, oh gosh, that was shocking. All of these second coordinates here have stayed exactly the same. But what has happened is that the x's have changed signs. So if we go and have a look at my original A x coordinate that was -5. It then changed to become a +5. The original x coordinate of B was -2. It changed when I reflected to become +2. The original x coordinate for C was -1. It changed to become +1. And so when creating this mirror image, when I go over the y-axis, I'm changing the sign of x. And that makes sense. I'm going from where all of my x's were negative on the left to now where all of my x's are positive when I create that mirror image. All right, now don't stress too much about this. It's just like these patterns you need to start picking up on. We will speak about them more and more every year, but it's just things to start noticing. All right. Okay, I unfortunately your name here is iPhone, but if you have a question you can ask.
Ma'am, I don't understand C.
Okay, what don't you understand?
How ma'am got the answer, ma'am, for C?
Okay, for the whole question C or for the coordinate C?
The whole question C, ma'am.
All right, so did you understand what I was speaking about earlier when I spoke about the fact that they must be the same distance away from the line of reflection?
Yes, ma'am.
Okay, so that's all this is. So this stuff that I've put on the side here, don't stress about. Like, this will come up again and again, and we'll talk about it again and again. But as long as you remember that the same distance must be applied on both sides of my line of reflection to get the coordinates, you can find the reflection.
Oh, now I understand, ma'am. Thank you.
Good, well done. Alrighty, guys. Please, can we remember to take screenshots? I really don't want to have to go back and forth between questions. So please take your screenshot of C. I'm going to go back to B so that you can take screenshots, but please do remember to take your screenshots as we go along. Right, there is B again, if you need it. Right, let's have a look at the other type of reflection that we did where we reflected about the x-axis. Okay, so once again, with reflections, we always need to have what we call a line of reflection. In this case, I'm telling you to reflect about the x-axis, and so the x-axis is going to be the mirror. Okay, so as I've just said, it's the same concept here. I need to make sure that when I create my mirror image, it is the same distance away from the original. So if I start with point A, the original point A, the original point A is 2 units away from my line of reflection. So when I create its mirror image also needs to be 2 units away from the line of reflection. And so A dash is going to end up at -3, -2, because that is where it is, when it is the same distance away from my line of reflection. Alrighty, would someone maybe like to give me where the new coordinate for B dash is going to be? Right, our QA, would you like to give me B dash?
Yes, ma'am. And the coordinate is -2, -1.
Excellent. -2, -1 is where I will find B dash. Thank you. Well done. All righty. Claire, would you like to give us C dash?
Yes, ma'am. C dash is 2, -1.
Excellent. So, C dash is going to be at, C dash is going to be at +2, -1. Excellent. Thank you. Bonganele, would you like to give me a D dash?
Ma'am, E dash should be 4 and -4.
Excellent. 4 and -4.
Yeah.
So D dash will be down here. Once we've done that, we take our ruler and we draw in our quadrilateral. Hopefully yours looks a bit better than mine. And we can see that what we've done is we've created this mirror image where the mirror is my x-axis. Okay, again, we can start to see some sort of like patterns going on if we compare the original to the new coordinates. So if I just write down my original coordinates very quickly, A, B, C, D, just wanted to make sure I left myself space there. Hopefully what we can see is that now the y coordinates are the ones that are changing a bit. So if I have a look at all of my x coordinates, all of the first coordinates, they are all exactly the same. They haven't changed. But what has changed are all of my y coordinates. So if I go and have a look at the original y coordinate for A, that was +2. When I reflected, it became -2. The original y coordinate of B was +1. When I reflected, it became -1. And this is now a pattern that I'm seeing for all of these. The y coordinates are changing their sign. Now this makes sense. I'm going from a place where all of my y coordinates are positive to a place where all of my y coordinates are negative. And because I'm flipping down, the signs should indeed change. Alrighty, so just quickly again, why did I get D at 4, -4? If I go to the original coordinate D, I can see that this is 4 units away from my line of reflection. And so when I create its mirror image, the point also needs to be 4 units away from my line of reflection. And so it's now at +4, -4 on the other side of my line of reflection. So Matlogonolo, was that your question that you put on the chat?
Yes, ma'am. I might understand now.
Okay, good. Well done.
Thank you, ma'am.
Alrighty, guys, so take your screenshots. But essentially what we need to remember is that shapes or points that are going to be reflected, need to be the same distance away on either side of the line of reflection, and that's how we can find the coordinates. We can sort of like go the step further and see these relationships of if I'm reflecting about the x-axis, the y coordinate sign was changing. If I'm reflecting about the y-axis, the x-coordinate sign is changing. But sort of like we are going to reinforce that over the years as we go along. So it's important to start noticing these relationships. But as long as you know how to do this reflection, that will also go a long way when we eventually start talking about these relationships again. Okay, so again, take your screenshot if you need. Okay, let us have our little brain break here. So if you're new, a brain break is basically just us taking a break from the maths that we're busy doing. I just want to try and make it a tad smaller. It's an opportunity for you to get up, to stretch, to move, try the little brain teaser or the puzzle that I've put up there for you. And it's not very long, so if you need to run to the loo, you definitely can do that, but we'll take about 5 minutes and then we're going to carry on with our transformations. So the brain break here, what we're wanting to do is we're wanting to work out the value of the football, I know I should know what that is, but for the life of me, it's gone. The pool ball, that's what I was going for, and the basketball. We need to find the values of those different things in order to go and work out the value of the last expression. Just remember, guys, your order of work, so the order of operations or BODMAS is very important. We need to remember to apply those as we go along. I can already see some hands, which is awesome. Right, Lundeka, do you want to give us the value of anything here?
Ma'am, I think the first one is 9.
Excellent. So each of these footballs are or have a value of 9. So every time I see a football, I know it's 9. Excellent, Rodeko, well done.
Thank you, ma'am.
Okay, so we've got our first one. Vanele, would you like to give us another one? Vanele?
I think it's network on Banele's side.
Okay, if you want, you're welcome to pop it in the chat for us. Alenka, would you like to give us one?
Yes, ma'am.
Awesome. Which one? The 8 ball.
I said 9 times 5 plus 5 is 50.
Excellent. So guys, what we need to be mindful of here is the fact that the 2 8 balls have to be the same value, but in one case I'm multiplying by 9 and then I'm adding. So 9 times 5 is 45, and if I add another 5, I'm going to get 50. So they have to be the same, and according to my order of operations, so doing multiplication first, I get my 50. Excellent, well done. Rado. Okay, I'm sorry, your name isn't here. Mr. iPhone. Do you want to give us another one? Okay, while we're waiting there, what we need to then remember is that if 1 8 ball is 5, every time I see 2 8 balls, I have a value of 10. So I do actually know the value of the double 8 ball because it'll be double 5. So, okay, let's try Bontle. Bontle, would you like to give us the basketballs?
Ma'am, I think the basketball is 6.
1 basketball.
No, I think both of them. Because ma'am, I said 10 times 6 equals 60 plus 10 is 70. 170.
Okay, but be careful. Yeah, exactly. It needs to be 170, not 70.
No, ma'am, sorry, I said 10 times 6. Oh, sorry, sorry, mistake.
Okay, but you're really close. What's 10 times 16? Oh, okay. Yolisa? Oh, guys. Okay, so, okay. Bonganele, do you want to help us out here?
Ma'am, wouldn't the basketball be, wouldn't it be 16?
Excellent, well done. So guys, the double basketball would be 16 because 16 times 10 is 160 plus 10 takes me to 170. So our double basketballs here are 16, which means that now I can go and find the final value. So Mona Lisa, would you like to give us the final value here?
Yes, ma'am. The answer is 169.
Excellent. So which operation do I do first?
The times.
Good, well done. So guys, this is what I was saying. We have to do order of operations. So 10 times 16 is 160 plus 9. And as Mona Lisa said, 160 plus 9 is 169. Well done, guys. Well done on picking up on those operations and the double values and so on. You guys did very nicely.
Yeah, my people are doing great there. I'm following you guys and I'm like, yeah, we're nailing this.
Okay. We still have 2 hands up, Bonganele, and again, don't know your name, iPhone. Maybe if you just let Yolanda know what your name is, we can change it so we don't have to keep calling you iPhone. But if you've got a question, keep your hand up. Otherwise, we're going to move on to our next transformation.
Yep, I can change it for them.
Jabulo, do you have a question?
Yes, ma'am. I wanted to ask if ma'am, I have homework. So if we're done with the lesson, are we doing the homework? I'm actually not sure because I just started. I'm new, ma'am.
So I'm still carrying on with the lesson for another 20 minutes. We're still going to do another few examples and then there's still the quiz, but obviously I mean, I can't keep you here against your will.
Yeah, no, hi Jabulo. Sorry to just say, I'm just gonna answer Jabulo also. Hi Jabulo and welcome. Okay, I know that you're a new student, and so here at Watobe, we basically don't help with homework. We sort of teach the contents that they're teaching you in grade 8. So after this lesson, if you need help with homework on a specific things that we're not doing now, after the lesson, you're allowed to go to Watobe website, check on our content that we've already done, because we've already posted like previous lessons. So you can go on those previous lessons and try and watch and understand, so in order for you to get help with your homework. Okay, I hope that's clear, our girl.
Yes, ma'am.
Okay.
Thanks, Linda. I misunderstood. Thank you. Alrighty, guys. So let's have a look at our next transformation here. So the third type of transformation that we spoke about was rotations. So again, there's a couple different ways that we can deal with rotations, and you have to decide what you're more comfortable with. You might have learned it slightly differently in class. I do think that the way I do it is quite simple, but again, you need to find what works for you. So the first thing about rotations is we need to know what direction we're moving in. And the second thing we need to know is how far, so how many degrees am I rotating my shape? So this instruction says, rotate the triangle ABC 90 degrees anti-clockwise about the origin. So we now need to go back and, yeah, apparently that makes sense. We now need to go back and figure out what does anti-clockwise mean. If we think about a clock, a normal sort of hand of a clock will move in a clockwise direction. So in this direction, CW means clockwise, which means that the opposite direction is anti-clockwise. So going the other way around the circle is counterclockwise or anti-clockwise. So basically what this means is that this triangle needs to move this way for 90 degrees. Okay, now, the way I like to do these is I like to use or imagine rectangles. Now, again, I would draw these in pencils that you can erase them. But basically what we want to do is we want to draw a rectangle from my center of rotation, which in this case is the origin, to have one of the corners of the rectangle touching one of the corners of my triangle. So there is one rectangle to the corner or to the vertex A. I can now take this rectangle, which is currently lying flat, and I can rotate it 90 degrees to create a new rectangle and therefore get my new coordinate of A. So remember, the dimensions must stay the same. It's 2 units wide and 5 units long. So now when I make it stand straight, it needs to be 2 units wide and 5 units long in my rotation. Bear in mind where coordinate A was. So when it moves, coordinate A must stay in the same position. And so A dash is now going to be at the point 2, -5. And that is just through using my rectangles. I can do the same thing for B. So B's rectangle is a little bit smaller. It's 2 units long and 1 unit wide. It's also lying flat. I'm going to move it so that it stands straight. So it's still 1 unit wide and 2 units long, just standing upright. And coordinate B must stay in the same position on the rectangle. So B dash is now at 1, -2. Finally, C. And this is why I'm saying draw your rectangles in pencil, because it can become a bit overwhelming. The rectangle for C is like a long, skinny rectangle. It's 1 unit wide and 5 units long, but this rectangle is standing upright. So now I need to turn it, and that's a poor way of just using my hand. It's standing upright. I now need to turn it so that it's sitting flat. It must still be 1 unit long, but now it's 1 unit wide, but it's 5 units long. And so now when I move my coordinates of C, it must stay in the same position. And so C dash is sitting at 5, -1. And so what we're doing here is we are using rectangles drawn from the center of rotation to each vertex of my triangle, and we are moving the rectangle either from a position of lying flat to a position standing up, or a position standing up to it lying flat. And through doing that and keeping the point at the same position on the rectangle, we are able to rotate the triangle according to the instruction. So if I now want to draw in my triangle, which I'm going to try do a little bit neater here. Obviously, you use a ruler. We now join all of our vertices. And we get our rotated triangle. Oh, I thought it was going to be neater, but I don't think it is. Now remember, like I say, you're going to use a ruler to draw in the lines or the sides. Which is what I was trying to do here, but it's yours will probably still look neater than mine. I'm not going to fight. And the last side over there. And so we have rotated this triangle, we've taken it and we've spun it around the central point 90 degrees to create my rotated image. Right, so I'll leave the rectangles on for a second if you want to take a screenshot of that with all of the working out. And then what I'll do is I'll take the rectangles off so that you can see, hopefully a little bit clearer, the rotated image. We are going to do another one. So this is a bit confusing. Don't stress. We're going to do another one. But essentially what you need to do is you need to be able to turn each point 90 degrees. And I find the easiest way to do this is drawing in a rectangle and moving its position. Right, so again, take your screenshot if you wanted with the rectangles. I'm going to take them off in a second so that you can see what the rotated shape looks like without all the mess. Okay, if I take this all off, I can now see my rotated shape. So you almost need to imagine it's being like attached by a string to a pin in the middle, and I'm moving the string 90 degrees to create my mirror image. And so I've swung the triangle 90 degrees to create that mirror image. Not mirror image, I'm using the wrong words, I do apologize, to create that rotated or turned image over there. Okay, I'm hoping we all have our screenshots. I'm going to move on to the next question here. So question F is still a rotation, still working with 90 degrees, but now we're going clockwise. So we know that that's now means a change of direction. Clockwise means following the clock hands. So I'm going this way. I'm moving into the next quadrant. Right, we're going to do a similar sort of thing to do this. I'm going to start off and then I'll ask for some coordinates as we go along. So if we start with A and I draw my rectangle so that one corner of the rectangle is on A, I get, oh, that's such a gross rectangle. I'm going to try. All right, I'm going to try again to draw a rectangle because that was ugly. If I draw my rectangle, there it is. That was better. Okay, this rectangle we can see is 2 units long and 1 unit wide. So now I have to take it from lying down, so lying flat horizontally, to standing upright so that I'm rotating 90 degrees. That then means I need to draw my rectangle, still 1 unit wide and still 2 units long, but now standing upright in the correct quadrant for my rotation clockwise. Now, what I also need to remember is that point A was sitting on the sort of right vertex. So when I move it up, point A is still at the same position on the rectangle. And so A dash is now sitting at 1, 2. Okay, so imagine that rectangle being turned up into a upright position rather, and we can then see where coordinate A is. Right, would anyone like to try? Tell me where coordinate B dash is going to be. You can take a second if you need to give it a try and see if you can work out where B dash is going to be. Nice. Wangi, do you want to tell me?
Ma'am, I said it's 30, is it?
Why 30? So if we draw our rectangle here from B, do you agree it's that purple rectangle that I've just put in there?
Yes, ma'am.
Okay, cool. So now that purple rectangle is currently standing upright and I need to put it on its side. And so that rectangle is now going to sit like that. Agreed?
Yes, ma'am.
Okay. So if
okay.
So where's it going to be?
3, 2.
Excellent. Well done. So B dash is at 3, 2 because now it's in the same position. When I move it, B dash must stay in the same position. Excellent, Wangi. Well done. Okay, Fazika, would you like to give me C dash?
Ma'am, the answer is 7, 1.
7, 1 or 1, 7? Oh, I'm so sorry, guys. I don't know what I'm doing here. Okay, so Fazika, the reason I'm asking this is because if I draw in my rectangle, it's currently sitting flat like this. So when I now rotate it, it's going to sit up like that. And of course, I haven't given myself enough space. Do we agree?
Yes, ma'am.
And so the coordinate C dash is going to sit up here at +1, 7. Sorry, guys, I didn't give myself enough space. Are you in agreement?
Yes,
awesome,
yes,
well done. Okay, so I apologize. I didn't leave enough space on my Cartesian plane. That's my own fault. But we take our rectangle, which is currently lying flat for C, and we turn it upright. So it's still 7 units long and still 1 unit wide, but now standing upright. And C dash is now sitting at 1, 7. From this point, I can now draw in my triangle. I'm not even going to try do straight lines. I'm just going to draw it in. You would use a ruler. But there is my new triangle, A dash, B dash, C dash. And this has come from me taking the red triangle and rotating it 90 degrees. Okay, by under, there's no D because I'm losing my mind. I had a triangle and said quadrilateral. I do apologize. Let's just change that. Thank you for pointing that out. But Plogonolo, do you have a question?
No, ma'am, I raised up mine by mistake.
Okay, no problem. Okay, so guys, apologies. I put a D there when there shouldn't have been a D there. So thank you, Bayanda, for pointing that out for me. Again, I'm going to leave the rectangles on so you can take a screenshot if you want, and then I'll take them off so that you can get a screenshot without the rectangles if you would like. All right, here it is without the rectangles drawn in. And so again, I would do the rectangles, but do it in pencils that you can erase it afterwards, and then you're just left with your triangle. And we can quite nicely see this in this case. The triangle was originally sort of lying flat on its longest side, but now when I've rotated it up, its longest side is sitting, or the side that was originally flat is now standing directly upright. And so we can now quite nicely see this rotation 90 degrees. All righty. Okay, guys, we're doing so well. We've got our last transformation to do and then quiz time and we're done.
Yippee! Y'all are doing well. So remember, if you miss anything, you're allowed to still go back and and rewatch the lesson, okay?
Alrighty. So the last transformation that we have spoken about are dilations or enlargement or reductions. Now, oh golly, the easiest way to do an enlargement or a reduction when the center or where the origin is the center of dilation is just to times by your scale factor. So my first question is going to be, can anyone tell me the original coordinates of this triangle? So the original A, B, and C coordinates. Okay, Bontle, give me A.
Ma'am, A is 1, 1.
Excellent. So A is sitting at 1, 1. Matlogo, oh, yo, my words there. Matlogonolo, give me B.
Ma'am, B is 4 and 1.
Excellent. 4, 1. Tiamo, can you give me C?
C is 3 and 3.
Excellent. C is at 3, 3. Okay, so those are my original coordinates. I need to know what my original coordinates are in order for me to go and eventually multiply. So if you haven't been given them, or if you have to read them off, maybe just make little notes that you can go along. Right. So the instructions tell me to enlarge the triangle by a scale factor of 2. Now, basically what that means is double the triangle size. And so what I need to do to all of these coordinates is I need to times it by my scale factor, which is 2. So when I go and multiply both the X and the Y coordinates, I'm going to get my new coordinates. So I'm going to do the first one to show you. I would times both the X and the Y by 2, which means that the new coordinate A dash would now sit at 2, 2. Right, Tiamo, do you have a question, or would you like to give me the new coordinates of B dash?
I would like to give the new coordinates for B.
Awesome.
B is 8, 2, 8, 2, 8, 2.
Excellent, well done. So guys, just by timesing the original coordinates by 2, I get my new enlarged coordinates. Fazika, would you like to give us C dash?
Ma'am, the new coordinates for C is 6, 6.
Excellent. So again, I times my original coordinates by 2 and I get my enlarged shape. So now where I know, or rather now that I know where my new coordinates can be, I must plot them. So 2, 2 is over here. It doesn't matter that the shapes overlap. That is okay. You've done it correctly. You've enlarged it as you should have. It doesn't matter. B dash is at 8, 2. So over here. And C dash is at 6, 6. So up here. And now when I draw in my triangle, obviously you're going to do it with a ruler. I can see that I have made this triangle 3 times bigger than the original blue triangle. Weird looking C dash. Okay, so I see some hands. If your hand is up to ask a question, you can leave it up. Otherwise, please do put your hand down. Right, Siamtanda, do you have a question?
No.
Okay. Bayanda, do you have a question for us?
Yes, Miss, I do. Miss, I wanted to ask you that when you did the A, B, and C at the top in blue, you didn't put the dash apostrophe thing at the top, but when you did it at the bottom in red, you did. So if you leave it out in the exam, do you lose marks, or you don't really have to put it in, or is it a must?
Okay, so the reason I didn't put it in for the blue is because that was my original coordinates. I only have to put the dash in when it's the new transformed coordinates.
Okay, Miss, thank you.
Okay,